This is the 7th video in my series on three-phase power transformers. In this video, I'll be looking at Y delta connected transformers. You can find out more on this subject in my course entitled Electrical Three-Phase Power Transformer Fundamentals. You can access this and my other courses on my Stan Store at this web address. For a star delta connected transformer, we have already gone through the exercise of seeing how the high side of a star connected transformer is, as well as we've gone through the exercise of connecting the low side in a delta connection. However, I'm going to go through the process now because this is the first time we're looking at connecting Y across to a delta. One terminal of the primary terminals are connected to the system lines or buses, and the other terminals are connected together to form a primary neutral. In the secondary of the transformer, one terminal of the secondary terminals are connected to the system lines, buses, etc. The other terminals are connected to the adjacent secondary terminals. The high voltage H2 terminals are connected together to form a neutral, and the H1 terminals are connected to the individual phase conductors. The transformer having the H1 terminal connected to the red phase bus is referred to as the red phase transformer. Likewise, the transformer with the H1 terminal connected to the white phase, it is referred to as the white phase transformer. And the transformer with this H1 terminal connected to the blue phase bus or line is referred to as the blue phase transformer. The X1 terminals of the transformer are connected to the individual conductors, and the low voltage X2 terminals are connected to the adjacent secondary X1 terminal. Before going any further, I want to explain the nomenclature that I'm going to be using in describing the voltages of the transformer, primary and secondary, as we go forward. You've already seen that I'm separating out things in color to make things a little bit easier to understand. When I'm talking about the primary side voltages, I'm going to use uppercase letters or capital letters R, W, and B for red, white, and blue. And if I'm describing the voltages in the secondary side of the transformer, I'm going to use the lowercase letters R, W, and B. If we're talking about phase-to-phase values, I will use both letters. In other words, if the voltage is red to white, I will say RW, and if it's white to blue, I'll say WB, and etc. I will use color, and they should make sense, but don't necessarily. The thing that's most important is the letters themselves, the R and the W, not necessarily the color, although I will try to maintain some sense in regard to the color. But as you can see, it gets a little bit confusing when we're talking phase-to-phase values because we're talking about two colors. However, I think it'll be pretty obvious as we go along. And if I'm talking about phase-to-phase values in the secondary, I'm going to be adopting the same standard, except that it's going to be lowercase letters. Now, when I talk about the phase to neutral voltages, they are, and they should always be, two designation or 2 points, because that's what describes a potential difference. So in the case of the primary side, I'm going to be using capital letters again, red to neutral, white to neutral, blue to neutral. In other words, RN, WN, BN. And in the secondary, I'll be using lowercase letters, RN, WN, and BN. Now, I'm going to make one exception, and that is because we are going to be trying to get everything condensed onto one slide in cases, I will be taking the liberty of dropping the N or the neutral. So a lot of times I will be referring to the phase to neutral value with just the upper or lower case letter. Now, in a Y delta transformer, of course, there is no neutral, but we will be talking at times about a hypothetical neutral, in which case I will just be referring to phase to neutral value with just the one letter. This could lead to some confusion as you go forward, but I'm going to make sure that things are pretty clear as we go along. And even though I should be having the N in there, you will see it's clearer and easier to understand if I do leave it out during the analysis. So the connections are fairly straightforward because this is the second time we've gone through them. The thing that is different, though, is the phasor relationships between the primary and the secondary. Comparing the phase-to-phase voltages, starting with the red to white phases of both the primary and secondary. Looking at the primary side, the phase relationship tells us that the phase-to-phase voltage is √3 times the phase-to-neutral voltage, and the phase-to-phase voltage leads the phase-to-neutral voltage by 30 degrees. And because the phase-to-neutral primary is magnetically linked to the phase-to-phase secondary, let me repeat that, because the phase-to-neutral primary is magnetically linked on each transformer to the phase-to-phase secondary, as you can see from the phasor diagrams, the phase-to-phase primary leads the phase-to-phase secondary by 30 degrees. And the turns ratio is given by the magnitude of the primary phase to neutral voltage over the magnitude of the secondary phase-to-phase voltage, which means the secondary red to white voltage is equal to the primary red to neutral voltage divided by the turns ratio. Or mathematically, you can also say that the primary red to neutral voltage is equal to the turns ratio times the secondary red to white voltage. We're talking about magnitudes here, of course. And it relates the primary and secondary phase-to-phase voltage magnitudes. Since we already know that the secondaries lags the primary by 30 degrees, then we can calculate the primary and secondary phasor relationships for a Y to delta transformer. In my next video, I'll be looking at current flows in a Y to delta connected transformer. However, I have run out of time for this video, so be sure and stay tuned to the next video where you'll discover the phase relationships of current flows. As I've said before, you can find out more on this subject in my course entitled Electrical Three-Phase Power Transformer Fundamentals. You can access this and my other courses on my Stan Store at this web address. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. Some of those products include 𝐃𝐈𝐒𝐂𝐋𝐀 big and small standby generators. This is the best time to try out any of EcoFlow products because they are having a huge sale starting on April the 4th and lasting until April 21st. Here are just a few of their products, starting with the EcoFlow Delta Pro Ultra, including the River line of smaller standby generators, and a range of portable solar panels, and finally a unique product, the Wave 2, which is a portable air conditioner / heater. As I said, this is the best time to try out any of EcoFlow's products because it is having a huge sale starting April the 4th and lasting until April 21st. During this time, you can experience huge savings off the original market price. To obtain more information on this subject, then pick up your free digital copy of the Ultimate Guide to Residential Standby Generators. Simply fill out the information requested when you go to this website, https://lowercase bit.ly/4/4X_D_X77. Before I end this video, I want to repeat the connection to obtain my free copy of the Ultimate Guide to Residential Standby Generators and receive access to the major April sales on many of the EcoFlow products. Also, here is a connection to obtain a free copy of my 50-page electrical power crib sheets. And finally, here is the link to all of my electrical courses, which are located in my stand store.